Perfect. So let's start with the project. So today I'm here to present the SMT processing line, which is a technology for used for surface mounted. So here there is the conceptual schema. So what you can see here we have the source that is generating three different parts: PCA type A, B, and C. So those are empty part, and then there is a solder pass, which is a machine that is set some pass on top of the empty PCB, which then is used for soldering all of them together. Here we have a buffer, because the idea is that when because the assembly line will take more time than the previous machine, so to avoid that the soldering finish to process a PCB and finds the other one the following station block full busy, then we want to avoid the weight. So therefore the buffer is there to offset this kind of risk. And then there are three assembly stations, which is 1, 2, and 3, and there is always a buffer in between, because each single assembly station is slow. It takes more time to process the parts compared to the previous one. Therefore I think that the buffer is the best solution to increase the throughput of the system. Then the throughput is the flow. Then there is the reflow one, which at the end does the merge of attach all the components, and then we have a process which is an OI, which is automated optical inspection, where the pieces the parts are inspected to see if there is any issues. Here we have an assumption also that all the rework is there is an assumption that is also part of the requirements, that 80%, 85% are successfully inspected, so there is no issue, and then the other 50% instead they go through the manual rework, and the assumption here is the manual rework is 100% successful, so there is no scrap there. We have a buffer then after the OI, because for the same logic as before, so we want to avoid that the next that the parts remain inside the system. We want to make it free for the following parts to be processed. There is the sorting and packaging. Here we get done this a single block, but here in the simulation the logic here has been better extended. We will see in a while. There is a buffer. Here the buffer is set as set to simulate the fact that after the boxes are generated, they need to be let's say stored in a place ready to be picked up and then to be shipped. So this is what the logic of the basic the buffer here. Exactly. So the buffer here is set to reduce the lead time. Also, other assumption that has been made is that the past is the same applied to all the PCBs. More or less, the three types of PCB they have different shape. Let's suppose there are some and also what we have said is that we used also simplification. The three components are chip, resistors and capacitor, and the packaging assembly has been also simplified. So here we go in the logic. So we have more or less as we discussed during the conceptual model, we have a source that has that uses a table for the three different packages. Also we have also table for the time that has been assigned to the stations. Here what we see here, there is the logic is to use electronic components to simulate those electronic components that are added on top of the MTPCB. So the PCB is simulated as a container. So there are three. So therefore, in each assembly station there are other electronic components that are added on top of it. Then what we then it flows through go through all the assembly stations. Then there is a buffer, there is a reflow, which is a single process. So therefore the components enter inside and they go outside. The AI also is a single process, and then we have the logic of the packaging. So here we have all the PCB that are coming through. Here we have a source that generates a box, and those boxes then are going to the assembly station. So here we have done we used 4 different assembly stations to assemble the box with a part, and each of them they handle the logic. Like for example, this uses a PIX 4 PCB type A in a box type A, and then the type B with the two PCB type B, and so on and so forth. And then there is exit buffer, which is where the pieces are stored, and then the shipping phase. So what we have here the modeling, just I want to show you that here this PCB are used as a container. My software is in German, therefore this is equivalent of in German of container. Here we have 50% of the components type A, 30% of type B, and 20% of type C. So also what you can see here in the printer station, we have also different type of processing. One means for PCB type A, 1 means and half for PCB type B, and then if you go to the next, so this is what we said before. There is many nothing to add. Also, this is a single process. Here we have the time that are going to be used for a work process, and which are like 20 minutes for type PCB type C, 10 minutes for type A, 15 minutes for type C, and this is the logic for the for the packaging. So again, the different assembly line. The boxes they are assembled with the PCB that are coming from the line. Exactly. So we use the previous parts to fill these things. There are some improvements that could have been done. I mean, those are not really improvements, but I mean, there's a different way of doing it. Especially regarding the packaging. For example, I used the assembly line, but it could have been done also with the transfer function or the transfer function or transfer station. But I tried also to do it, but it seemed, but they had issues with the sensors there. I mean, all the stations were red, and only 3 stations were red. One was gray. So I spent like 2 days to troubleshoot. I prefer to keep it simple, and the worker also could have been added there. But I prefer to avoid this to insert the worker, because already the logic, the simulation is already messed, and it is better to read in this way. So also to spend some word regarding the bottleneck analysis. As you can see here, this simulation run for a long time. We see that the majority of the stations they are in waiting time, so the part they are waiting. So this is you can see that everything is problematic. There is some station that they have an high low availability, and for example this assembly station, also this packaging here. So the station, the bus stations, the reflow is mostly free, and also the AI. So the assembly station that are more or less the bottleneck here, and could be improved to, let's say, create a parallel line here, for example. Here we see that the boxes are passing through. And so now to conclude, there are those are the say literature that I used for the systems, because we have an interconnected system, so every system depends for the next one. We use the buffer to overcome the common string theory. We use also verification validation to perform. So thank you very much for watching it. Bye.